when we divide complex numbers, divided by complex, we want to get complex at the end, right? So if you have, for example, a plus bi divided by c that plus di, for example, then you expect to have something like this, e plus fi, for example, right? So that means what? That means the imaginary will be up. It cannot be down. It has to be up. So that's the main idea that we have, the main problem that we have. So if I have this example, like I have 3i, as an example, I just make this in a different color. If I have 3i, for example, divided by 5 minus 2i. See, this is a complex number, and this is a complex number. Of course, this is only imaginary, but the idea is I don't want the i to be down. How do I get rid of the i down? We just use the property I told you about, which is a complex conjugate. If you multiply this by, we try to multiply this by something up and down. So we try to multiply this by something up and down and see if we can basically get rid of this i. So how do I get rid of this i? What should I multiply?
5 minus 2i.
Exactly. The complex conjugate I just explained now. 5 plus 2i here and 5 plus 2i here. Because when you multiply by complex conjugate, of course multiplication means what? Up times up, down times down. We did this with fractions yesterday, remember? And in this case it will be the 3i will be multiplied by the 5. You get what? 15i. And then the 3i will be multiplied here also.
6i squared.
Which will be?
Minus 6.
Do you understand what's happening? Yes. Any questions here? You want me to explain this again? So the numerators together, which will be 2 times 3 will give you 6, and then you have I squared. Down is the complex conjugate property, which I explained earlier. 5 times 5 just 5 squared, right? I just had 5 squared plus what? Plus 2 squared. I don't have to think about how this happened. There's a property that I should be aware of. Okay? I proved it before. So that will be a real number down, and that's the main idea. I don't want to have imaginary down. I just want to have real. Imaginary must be up, only up, like here. That's the main idea of how I divide. I remove the imaginary down, that is down, by multiplying by the conjugate. But to do this, I have to multiply up and down, because I cannot change the fraction value. How to maintain the fraction value? By multiplying the same quantity up and down. That's the only way to maintain the value of the fraction, and just change the shape, but the value is still the same. Okay? Clear why I'm doing this? Now let's just simplify this to understand what would be the final answer. Of course, we said before that I squared would be minus 1, so this will be minus 6, right? So I just write this as minus 6 plus 15i. Okay, I just put the real part in the beginning. Usually you write the real part in the beginning. It's okay to write it at the end, but it's better to be in the beginning. And then I'm going to divide this again by the real part, which is 5 squared and 2 squared. 25 plus 4 is 29. So this will be divided by 29. Okay, so this is the answer. You can also, if you want, to write this answer as a real part and imaginary part, because see, we're expecting the answer to be real part and imaginary part. So what's the real part here? The real part here is basically minus 6 over 29, and the imaginary part here will be plus 15i over 29. Okay, so that is now the real part that we're expecting and the imaginary part that we are expecting. That is the main idea how I divide complex numbers. If this is plus, then you have to make this minus, and you have to make this minus. That's the conjugate. You just change the sign. Okay, any other questions?
Can you repeat it?
Yes.